Welcome. This video is CCBYCN. All right, here we are starting chapter 5, and we're going to start with the law of cosines. Now, there is a law of sines. That's going to be a different video. And the law of cosines actually is not that difficult. To use law of sines, it gets a little tricky. The law of cosines, we're going to start with a non-right triangle. And how do we solve those? That's what the law of sines and cosines are for. So A, B, and C with sides A, B, and C. So we're given a non-right triangle. Actually, it could be a right triangle, but this is for any triangle. What we have is we have that C squared, side C squared, is equal to side A squared plus side B squared minus 2 times A times B times the cosine of angle C. Now, to use this, I'm obviously going to have to take the square root of all of this mess here. And what I want to point out is that it's the side, angle, side. So it's a side, the angle, and the other side that makes up that angle that we're doing this. And it's always what we're solving for, in this case, is always the side opposite the angle that we presumably have. Now, we could rewrite this with the A squared equals B squared plus C squared and so on. It's all the same formula. So just remember it's side, angle, side. And it's going to be sort of a theme. So law of cosines, we use side, angle, side. In addition to that, we can also use it for side, side, side. However, that comes from solving for the cosine of C. So when I solve for the cosine of C, that's going to give me A squared plus B squared minus C squared all over 2AB. Now, a couple of things I want to point out. The two positive parts on this are always the sides that make up the missing angle. So when we're looking for, if we have all three sides, side, 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 and we want to find an angle, whatever the missing angle is that we're trying to get, that's the side that we're subtracting in the formula as a way to remember that. All right, let's do an example. To find the distance across a small lake, a surveyor has taken measurements shown. Find the distance across the lake using this information. I'm going to call this distance D. And we can see that we have a side, angle, side situation. So this means that D is going to be the square root. All right, I have to take the square root of side squared 2.57 squared plus the other side 3.31 squared minus 2 times 2.57 times 3.31 times the cosine of our angle, 35.3 degrees. And here's how we use our calculator for this. You may want to get all what's under the radical first by itself and then take the square root. I'm going to do it all at the same time. So second square root. Oh, got to turn it on. Second square root. Now I have 2.57 squared plus 3.31 squared minus 2 times 2.57 times 3.31 times, and I'm going to double check that I am in degree mode, and I am. All the way to 0.31 times the cosine of 35.3. Close and out of the radical. There it is. So it looks like we're getting about 1.92, we'll say. You should be doing this in your calculator as we're doing this, not just watching me do it. And that's going to be miles. Yeah, make sure you practice your technology. specifically the calculator that the same calculator that you're going to use on your test. That way because if you get a brand new one or something, it may be a little different and it might throw you off. You don't want that during a test. Example 2. In an oblique triangle, ABC, so let's draw an oblique triangle, ABC. Oblique triangle just means that none of the three sides are the same. So it's ABC. We have side A is 45. Side B down here is 28. This obviously is not drawn to scale. And side C is 49. And they want to find the measure of angle A. So here's angle A. So as I mentioned with the formula, the subtract part of it is going to be the side that is the opposite of the angle that I'm looking for. So if I'm looking for angle A, the side opposite is there. That's my subtract. This is going to be the cosine of A is going to be 49 squared plus 28 squared minus the side opposite, the angle that I'm looking for, which is 45 squared over 2 times 49 times 28. Now I want to point out all this is going to get me is the cosine of A. If I want A, I'm going to have to do inverse cosine. So once again, make sure I'm in degree mode, degree. And I'm going to do inverse cosine. And I'm going to use an extra set of parentheses, 49 squared plus 28 squared minus 45 squared. I'm going to close the first set of parentheses, divided by parenthesis 2 times 49 times 28. Close and close. So make sure that you practice exactly what we're doing here right now. So I got this, and this matches my notes, so I think we're okay. But yeah, do this a couple of times in your calculator, just for the practice. 64.99 it looks like. That's degrees. If you're not getting this, I would suggest maybe that you do the numerator, store it off as a memory, do the denominator, store it off as a different memory, and then do inverse cosine of like A divided by B or something like that. It's very possible you're missing a parenthesis. The other common mistake is that you're in radian mode. And so you're getting some a radian answer instead of a degree answer. All right, moving on. Example 3, a pilot flies in a straight path for an hour and 30 minutes. She then makes a course correction heading 10 degrees to the right of her original course and flies 2 hours in her new direction. If she maintains a constant speed of 630 miles per hour, how far is she from her starting point? So this will be her start point. Start point. And an hour and 30 minutes into that, she makes a 10 degree. So if we continue this on, meaning this in here is 10 degrees. And she continues on for 2 hours, so a little bit longer. How far is she from her original starting point? Now, you'll notice that they give us information in terms of time. Now, an hour and 30 minutes is 1.5 hours, so I'm going to rewrite that as 1.5. And off to the side, I'm going to do some extra work here. And to be clear, what we're looking for is this distance here. So I'll call that D. So to find out how far, we're going to have to go back to an oldie but goodie. Rate times time is distance. So if this one is for an hour and a half, and she's cruising at 630 miles per hour, then the distance here, this distance is going to be 630 times 1.5 hours. So 630 times 1.5, 945 miles. So that's this side here. If I do the same thing here, 630, but now times 2 hours, 630 times 2 is 1,260. 1,260 miles. Now, we also have the small matter of this angle here. If this here is 180 degrees and this is at 10 degrees away from it, that's making this 170 degrees. So now we have side, angle, side. So D is equal to the square root of 945 squared plus 1,260 squared minus 2 times 945 times 1,260 times the cosine of 170 degrees. I'm going to quickly double check that I'm in degree mode. And here we go. Again, you may need to break this up into smaller pieces. My calculator lets me do it all in one piece. So this is 945 squared plus 1,260 squared minus 2 times 945 times 1,260 times the cosine of 170. 170 degrees. Here we go. So it looks like the distance from the original starting point to, I guess that's 3.5 hours with a course change, is about 2,196.78 miles away. Just by using our formula there that we've had forever. And our last example, a triangular field has sides of 20, 44, and 48 miles. From the largest angle, find the largest angle in degrees rounded to 2 decimal places. So let's draw. All right, we have 20, 44, and 48. And if you remember from geometry, the largest side is always opposite the largest angle. So when we're looking for the largest angle, it's going to be opposite the largest side. So this is going to be the minus c squared in the formula. Once again, the side opposite the angle you're looking for is always that minus part. So that's going to be the 48 in this case. So here we go. Cosine of theta is 20 squared plus 44 squared minus 48, there's my minus, squared, over 2 times 20 times 44. By the way, the 20 and the 44, the order does not matter. So theta is going to be inverse cosine of all of that. Now, I'm not going to do it all at once like I did in the previous time we used this part of the formula. I'm going to break it up like I told you with the memories. So I'm going to do the numerator, 20 squared plus 44 squared minus 48 squared. And I'm going to store that into A. So that's my numerator. My denominator, 2 times 20 times 44. And I'm going to store that into B. one was A. The bottom one is B. So I'm going to do double check degree inverse cosine of A divided by B, giving us about, right in blue, 88.96 degrees. Yeah, double check that radian degree mode every single time. I say it every video, and I will continue to say it. All right.